Let's get the meeting started here. So I'd like to call to order the April 12th Lewes Board of Public Works workshop on the long-range plan for the wastewater treatment plant. Thank you for coming out. So we have the board minus Tom Owen with us, Hans Medler from the county, Austin and Robin and Sharon. And online we have Mike Hoffman, our solicitor, Tom from GHD. Is Jeff with you, Tom, or?
Jeff, I believe, is online. I believe he signed into the call. Yeah, you may need to promote him separately as a panelist.
All right, no problem. So this is our fourth public workshop on the wastewater treatment plant. We will be having two more after this, one in May and one in June. The dates and times are online. The 17th of May, it will be in City Hall, not here. And then the 14th of June will be back here in the Rollins Center. And they're both at 6:30. As we talked last time, all the public comments are up online. Sharon's been making sure it's been kept up to date. The FAQs are up there also. There's no new ones since last time. The presentation material is also up online, and we have copies here for anyone who would like them. Since the last meeting, we held, the county was gracious enough to hold a tour of South Coastal County facility, and that was attended. And the last slide will say that we're having a tour of Wolf Neck. It will be the existing site, so it is not reflective of what would go in there, but just so people have a familiarity with the site. And Hans and the county have graciously agreed to host that. GHD is going to present the details of the report or the presentation later on. But there are a couple of things first I want to go through. There was an article in the Cape Gazette, and while it was completely accurate, I just wanted to make sure that we put it in the proper context. I did say, and we are going forward on pursuing option 3 agreement with the county. And that is part of the process of winnowing things down, because in order for option 3 to be viable, we need to address the cost, environmental, controllership issues, long-term maintenance aspects of it. So if we can't reach that type of accord with the county, then obviously option 3 will fall by the wayside. But option 3 is where we're working. The staff is working with the county to draft up an agreement to make sure that it is something that the county can live with and something that meets the BPW and its customers' needs. There was a comment in the article, and I just wanted to emphasize, if option 2 or 3 or some other option comes through, the plant will be demolished. It was kind of phrased a little bit as an open-ended in the article, but the plant, if it is not used, will be demolished. The future use is completely undetermined at this point. And as I said last time, the property is jointly owned by BPW and the city. So any use of the property would have to be done in conjunction with the city. we've heard a lot of comments, or no, I should say a lot. There have been several comments about, have we really considered all the options? So one of the things we're doing now is looking at the 1, 2, 3 ABC options that we have and making sure that A, we haven't left anything out, and B, that the cost numbers are fully representative, or are there alternatives in there that might affect the costing? So that is being done in parallel with our discussions with the county. And the article did bring up, and I know, Barbara, you're very interested in this, is, temporary hardening. It's an option, but I mean, I honestly have to say, from my perspective, it would be spending money that could better be used for a long-term solution. And it also doesn't assure us that a storm, hurricane, whatever, isn't going to come in the meantime. So the cost of hardening the plant would kind of be fixed, whether we do it for the next 10 years or out to 2050. But I personally feel very uneasy with that option. But as we recalculate and look at the options, we'll revalidate that. So at that point, I'm going to turn it over to Tom from GHD, and he's going to go over what we have is option 1 visuals, more diving into the cost estimates, and a slide to discuss the effluent into the canal for the options. So with that, Tom, I'll turn it over to you.
Thank you very much. Good evening, everybody. My name is Tom Biaggioli. I'm the GHD project manager for the long range planning study. And I'll be talking through the slide contents this evening. I'll just wait for you to get configured in the room. So as Tom said, I'll begin by walking through some option 1 visualizations for how the site would look after the option 1 components are put into place. Talk through cost estimates, specifically the capital cost estimates, the process that we use to generate them, and some key examples of differentiators between options. And then I'll talk about the water quality criteria. And these are all based on comments and questions that have been received previously, and we're just hoping to provide some additional response, some additional clarity on some of these issues. Can I have the next slide, please? So starting with the option 1 visualizations. So option 1, which is the existing site hardening, the upgrades include a new perimeter flood barrier and some new treatment structures. Specifically, and we're showing the layout schematic drawing on the slide here. The structure specifically would be a new flow equalization tank. And just make the comment that would be a 3 million gallon equalization tank, around 6 times the size of the existing tank. And also an extension to the MBR building and the new aeration basins. All of these things, as we've touched on previously, will have an impact on how the existing site looks. So we've been working with the board to put together some visualizations to try and provide an additional insight into how the site would look following implementation of the option 1 upgrades. So we can have the next slide, please. So this is what we're calling view number 1. So we have 3 views, and in each case, I'll talk you through a before and after shot, and then we'll go into a zoomed in version of the after shot to go into some of the.
Is there any way we can maybe not to push Tom off the thing? Yeah, show the things. There we are, Tom.
No, that's good. That actually helps me considerably as well.
Very friendly view that we had previously. Thanks.
Okay, excellent. This helps me too. I was following along on my own set. Yeah, so in each case, we have a before and after shot, and then we'll go into the visualization itself in a little bit more detail on the next slide. So view number one, sorry, can you go back to the previous slide? So for view number one, if I draw your attention to the legend in the top right-hand side of the slide, view number one is looking at the site entrance from American Legion Road. So we have before on the left and after on the right. And some of the key differences, which you can see are, well, one is the color of the grass. That's purely a graphics thing. But what the key change will be that the access road into the site will go uphill in the future scenario. And that's the new access ramp, and that takes vehicles up to the crest of the new perimeter flood barrier. If you can go to the next slide, please.
Can I ask a question?
Yeah, yes, please.
So on the green area in the bottom, which is the blower room and the aeration basin, are those larger than they are today?
So,
But it was up in the right hand corner. He was talking about.
okay.
So up in the upper right hand corner, you had the new aeration basin and you had the new blower room. Are those being built out further than they are today, I assume?
Yes, that's correct. And I'll talk about that in more detail on view number 3. But yes, those are an extension to the existing facilities.
Okay.
So for view number 1, the things in here which would be new in the future scenario are the perimeter flood barrier, which you can see there with the grass finish. So in the report, we provide some more details on this. This would be a compacted fill barrier with an impermeable layer within it to provide the flood proofing, but the finish itself would be a grass seeded bank. We have the new vehicle access ramp, and this would be at a grade of 1 in 20, which is the maximum acceptable grade for the large vehicles that are required to get in and out of the site in order to operate and maintain it. You can also see a new site fence up on top of the new flood barrier. This is because the compacted fill barrier would be at a slope of 1 in 2, which is very much accessible to pedestrians, and we still need to provide a secure site. So a new site fence, similar to the existing arrangement, would be installed on top of the compacted fill barrier. And then in the background, you can see the new much larger flow equalization tank, which would partially obscure the existing headworks building, which is what you see in the background there.
So Tom, if you can, just for perspective, the rise from the road to the top of the berm in the visuals, the option 1 visual, how tall is that in comparison to what's there now?
It's approximately 6 feet above the existing grade.
So if you were to pull out on the view more towards down American Legion Road, you'd see more of the perspective of the size of the berms.
Yes, yeah. And in fact, perhaps if we go to the next view.
So if that's 6 foot, how high is that above flood level?
That provides 2 feet of freeboard above the anticipated 100-year flood elevation.
Okay.
With at 2050 with sea
2050 with allowances for sea rise and coastal consolidation. Yes. Okay. So looking on to view number 2 now. So again, I'll draw your attention to the legend in the top right. This view would be along the western perimeter of the site, viewed from East Savannah Road across the marshes. So again, we have the before and after shot. Key differences you can see straight away is the new flow equalization tank, which would obscure the view of the existing headworks building. And then in the foreground there, you can see the existing flood barrier. As we've talked about previously and noted in the report, there are 2 different types of perimeter flood barrier. So where it's feasible and where we have enough space, we have the compacted fill barrier with the grass seeding. But because this is trapezoidal and we have the 1 in 2 grade, it has to go up to 6 or 7 feet. It's reasonably wide. It's about 30 feet total width. And that means we can only fit it into the existing site perimeter over a certain proportion of the perimeter. Where we can't fit it in, we've indicated a sheet pile wall, which is what you see on the left-hand side. The sheet pile wall has a much lower footprint, but it is more expensive. So where feasible, we would put the compacted fill barrier. You can go to the next slide, please. So again, the new components are the flood barrier, so the sheet piles on the left and the compacted fill on the right. The new site fence, again, above the compacted fill barrier, and the new flow equalization tank. And any questions on this? If not, we can proceed to view number 3. So view number 3 is a more of a diagonal view, looking from the southeast corner of the site, from up on the highway from Route 9. So again, looking at the before and after here, the key differences are again the relative size of the larger flow equalization tank, the perimeter flood barriers in the foreground, and then the building extension. So the aeration basins, the enlarged aeration basins would be obscured by the section of new sheet pile flood barrier, but you can see the extension on the MBR building with the new sloping roof. If we go to the next slide.
Before you do that, if I can ask my question. So on
Yes.
the where it's been built out further than it is today, is that land that we currently own?
Yes, that is. So the existing treatment plant, the area which is currently in use as a treatment plant is on a larger plot, which is all owned by the BPW, or the BPW and the city jointly, as we understand it.
Is that expansion into wetlands?
Yes.
So it is beyond the scope of existing subdivision that's already done. So you would need to readjust the subdivision plan.
Has that ever been finalized?
It is, the subdivision has been recorded, we're working on the deed for the subdivision.
Is that another way of saying that that's not necessarily our land now?
It is not jointly cut.
Okay, so that is not currently our land.
No, we would have to adjust that one.
Okay, got it. Thank you. I understand. I'm just trying to decide. We're trying to get the facts. Thank you.
Okay, so if we can go to the next slide. So again, explicitly pointing out the new additions. You can see the flow equalization tank, the extension to the process building, the MBR building, and the new perimeter flood barriers.
So I just want to point out to everyone that this is from the Freeman Highway directly above Gill's Neck. So this is the angle, if you look at it, is looking slightly downward towards the plant. It's not the Gill's Neck view looking up. So it does give it a different perspective, but you get to see more of it from up high. Okay.
If there are no further questions on the visualizations, those are the visuals that we've produced. Those are the 3 views.
Sure. You want to we can take the questions at the sections here.
Sumner Crosby, 558 Piletown Road. I'm sorry, I don't know the number, but how much bigger is that 3 million gallon equalization tank over what's there now?
It's 6 times the volume.
Thank you.
Barbara?
I forget.
Oh,
Barbara
can you-
Curtis, 17 Ship Carpenter Square. I forget, following up on Sumner's question, I forget why the equalization tank is so much bigger. Is that for capacity expansion or is that for storage? Why couldn't we just raise the size of existing tanks, I guess?
Tom, you want to take that?
Yeah, absolutely. So this tank is it's a flow equalization tank, so it provides a buffer for the incoming flows. And we have sized that for the future flows for the 2050 planning horizon, and we've sized it using the current industry best practice, which is sized it for what we call the equalized flow. And this is the size that's required. I don't know how the previous tank was sized, but in order to have a robust facility for the 2050 planning horizon, sized for the current industry best practice, this is the size tank that would be required.
So, and Austin, you can chime in. The current maximum flow rate is 1.1 million gallons we see during the summer peak.
Yeah, I would say that's about your average. It's between 1 and 1.1.
And so the plant we're going to size it for 1.75. You know, as we talk, and if we went with the county, it would be 3.5 for combined flows for any other plants. But so the head tank is for the third anaerobic beds, the increased flow, and also to give us more margin, because right now with 500,000 gallons, that doesn't give us a lot of leeway if something goes wrong in the plant.
Okay, I was just curious about why the existing tanks couldn't just be made higher, for one thing. And
I can respond to that. So I mean, raising the existing tank, first of all, the tank walls, I mean, they would have to be significant. I mean, you were talking 6 times the volume, so 6 times the height, so there'll be some structural stability issues. Also, the tank has to fit into the existing hydraulic profile on the site. So the flow equalization pumps that are in place would have to be considerably more powerful in order to raise flows to and from an elevation that's so much higher than it is at the moment.
And also, I guess with regards to MBRs, they have a fixed capacity by which they can pass flow through them. And so this is really based on GHD's recommendation that you really need to have a higher flow rate. And it's GHD's recommendation, but it's really based on good MBR design for what the equalization flow should be to make that facility operate correctly.
thank you, that's helpful. Another question, I think I missed it. The new aeration tanks, would they be built in the wetlands? Did I hear that said? And would that be a permitting issue? I would think it would be.
Yes and yes. They would need to extend out into the area which is currently wetland, and it would certainly be a permitting, certainly be a factor in the permitting, and that's factored into the MCA scoring.
So currently there's 2 trains, and the third train that we would put in would be on the marsh side towards the canal, to be able to give us the capacity. So yes, if you've been through the plant, I know
Yes.
it drops off rather steeply there.
Yeah, okay, thank you.
Any other questions on the visuals?
I don't really have any questions. Jerry Burden Kings Highway. Seems like we always have a double standard. Instead of putting a fence there, why couldn't we extend this, as you call it, compacted barrier? You know, I know that, and what I'm basing that on is because they're getting ready to dredge the canal and they're putting that waste there. Why can't we just actually extend that and use natural, instead of having grass, use natural, the cedar trees that grow up there, grown there, you know, many years ago, when the dump was on the other side of the old railroad track, you had simple things like raspberries, blackberries. You don't have to maintain it. It's still going to hold the soil. But again, why can't we use that as a barrier instead of putting the steel in there in the long run? That's one thing. And just bring that up. I can't really answer that. Or there's other, like I said, we always have a double standard. We can dredge a canal, but we can't put a little bit put a little soil in there. Second is, why don't we do a 99-year lease on that property like the rest of Lewes Beach in that whole area? And before somebody says anything about the industrial area, don't forget there were two very large fish factories, SPI and some of the other commercial there. So, why can't we, or the board, get a 99-year lease and not have to, deal with the city as much? Not that it's a problem, but it can be.
I'm not sure,
I didn't hear the last one.
can you, whether we can get the deed changed?
Yeah.
Or at least,
Make it a little easier, less paperwork. I
but
guess.
yeah, I mean, it still doesn't get to technical issues. And
That's
Tom-
true, but I'll just bring these little
Yeah.
things up.
Tom, if you want to address the stability of the berm versus a natural.
Yeah, I know it's built, I know it's the wetland, it's the marsh, actually. Yeah, I realize it.
Tom,
If I've understood the comment correctly, in terms of using trees and plantings to provide the flood proofing, we would have, there would be issues around whether that would provide flood proofing, whether that would provide an impermeable barrier. So within the compacted fill barrier, there would be an impermeable sheet, likely polyethylene, which actually provides the waterproofing. Because if it was just compacted fill and you had a flood elevation on one side, it at some point it would eventually just seep through. So it wouldn't really provide the flood proofing. Does that answer the question?
Yeah, somewhat. Yeah, again, I've been around, I have a son in the Netherlands, in Haarlem, Holland, so I don't know a little bit about that kind of stuff, because they're always underwater. So I didn't realize you were gonna put the plastic barrier. That's all, but I'll just bring that up.
no, thank you.
Yeah, and we would provide either plastic barrier or some type of clay, which has a low permeability. We could also substitute in there. And what we really decided was that if the slope, we were actually trying to maintain a 2.5 to 3 to 1 slope, which is mobile, and maintenance, you can keep up with the maintenance there. If that went out beyond the property line, that is when we chose to use the steel barrier, because it was horizontal at that time, or I'm sorry, vertical at that time.
Yeah, I just want to say, I just want to say that as an option. And again, I realize the barriers don't take up less land, by the time they spread out the basically the fill barrier. That's all I was trying to emphasize. And like I said, we always have two different standards. One minute it's, oh my gosh, this is the wetlands, the next minute we can do something else another time. I think we know what we mean by that.
Okay, in that case, Tom, we move on to the costs.
Okay. Okay, thank you.
Let me just preface, Tom. One of the comments that we've seen from a couple of people was that, and I hate to use the term, but the phrase was used, back of the envelope calculations for cost. The original study that GHD did included an Appendix D, which was like 30 pages of the calculations for line items for the costs for all the various options. And so that's what Tom's going to go over now, is trying to summarize that a little bit. But I encourage anyone who is interested and has trouble sleeping at night, huddle up with Appendix D. It has lots of numbers. And they're all real numbers, no imaginary. All right.
No imaginary numbers. Okay, thank you. Yeah, so as Tom was saying, we just wanted to provide provide an overview of the process that we use to come up with these costs, and yeah, really, and just talk through some of the key points. So everything starts with. So I've broken this out into 4 broad stages. Stage number 1 is the engineering analysis and the calculations. So we establish key technical parameters for everything involved in the upgrade. So everything from the flood defenses, how tall, how wide, treatment equipment, storage tanks, process tanks, pumps, pipelines. Everything stems from original engineering calculations. And really, I've listed some report sections here, but essentially everything that's in section 3 of the report, which is the main body of the report. All of the calcs, all of the graphics and the tables, really it's all the first stage in cost estimating. It's how we eventually come up with the quantities. And like I say, I've listed some specific sections here, and if there are questions on how any particular values are calculated, absolutely happy to take those questions in a session like this. Otherwise, they're all available in the report, either in the report or in an appendix. So that's the first stage. That's the engineering analysis. The second stage is to take those critical parameters identified and give them some physical dimensions so that we can start to think about process sizing and land use. So for example, from stage 1, and I'm showing an extract there, a table for the treatment stage sizing. We identify that we need an aeration lagoon with a certain surface area and a number of secondary clarifiers with a certain surface area. That's the first step, but then how far apart do these structures need to be? What pipes do we need to connect them? How wide are the site roads? What are the turning circles required? Where does the fence go? What's the offset from the public road? All of these things that flesh out those key technical principles into a physical site layout. And that enables us to set out the site layout schematics for the treatment plant sites, and also land areas required for the pumping station upgrades. So again, we calculate that we need a pump station wet well of a certain volume and a certain geometry. How does that fit on the existing site? What's the orientation? It's just giving it that physical dimension. How does it actually fit? And then again for the pipelines. So we know we need to get from A to B, or A approximately to B. But how do we go there? We don't go as the crow flies. Generally we try to follow public roads or other alignments that would actually be feasible to build in. So it's taking the outputs of the engineering analysis and fleshing them out to give them some sort of real world dimensions. Next slide, please. So having done that, we can then get into estimating the base cost for construction. And I'll just say, I'm just talking through the process now, specifically for the capital cost estimates, but it's really a similar principle for the operation and maintenance cost estimates that are also into the report. So this third step is really where we get into the detail of the cost estimating, and the cost estimates that we produced are what we call bottom-up estimates. So we look at all the individual components of the upgrades, of all the recommendations, and we go through them. Each one becomes a line item. Each one gets a quantity and a rate, and we build up the cost for each item. And by doing that, we develop the cost from the bottom up to a project level and a construction base cost. And even though we are at an early concept stage, we still go into a reasonable level of detail. For example, we start by looking at the existing site, and as Tom was saying, everything that's there will be demolished or decommissioned. So we have to quantify the extent of that decommissioning and demolition work. So which superstructures have to be taken down, which slabs have to be broken out and removed from site and disposed of, underground services, which of them can just be left, which of them need to be capped, which of them need to be removed. Each one of these actions has a cost component to it and gets broken down in the base estimate. We then look at the temporary facilities that are required during the construction stage, the means and methods. So we're doing a lot of excavation. How do we support the excavations? How do we do a groundwater? There's traffic management, stormwater management facilities, everything that enables these upgrades to actually be implemented at the site. Then we get into the permanent works. So a big cost is always earthworks quantities. So we're talking about, in option 1, we're talking about a compacted fill barrier. So we do cut and fill estimates for that. Process tanks, some of them are partly below grade. So what are the excavation quantities associated with that? Excavation quantities associated with pipelines. So the pipelines generally go in the ground. What are the trench dimensions? How deep does it need to be? And then once we've got it in, and we've compacted it, backfilled, generally in public roads. So what's the extent of the paving reinstatement required? How thick is the asphalt? What are the local standards for that? Then within the site, we look at concrete volumes for the new structures. So we set out things like aeration basins or clarifiers, different tanks. In the initial stages, we identify the, if you like, the functional dimensions, the hydraulic dimensions, but these are all physical structures. So what's the wall thickness? What's the assumed slab thickness? And we go through and we come up with a concrete volume for each one. Any new buildings get an architectural cost, and we develop a cost per square foot. And that includes components for building superstructures, for building finishes, cladding, roofing, heating, ventilation, and cooling. Those all factor into the square footage cost rates for the new above grade buildings. And then a big part of this stage, and a really important part to make sure that the cost estimates are keeping up with the current markets, is that we go out to the market and we coordinate with equipment suppliers in the area, and we get quotes for all the major process equipment that we've identified as required for all of these upgrades. So everything from the pumps, the transfer, the flows to and from the treatment plants, to all the process equipment, screens, mechanisms, reactors, everything, and also the sludge dewatering, solids handling equipment. So we get the cost from the suppliers to supply that, and then we also make allowances for the labour to install and commission that equipment as well. Other factors in large capital projects like this are what we call general contract conditions. So whichever option proceeds, this will be a large civil engineering project, and there'll be a main contractor, and they have costs associated with mobilizing on site and demobilizing, and also their operating overheads and their profits, which all has to be accounted for in the project cost. We also have electrical and instrumentation works, and at this early stage, it's difficult to go through and really itemize that work and do it to the same level of detail as the piping. So at concept stage, we estimate those as a percentage of the mechanical and process costs. And the way we choose those percentages are by looking at recent comparable projects. And we generally find that the electrical and instrumentation costs come up within a certain percentage component of the overall works. So by going through this process, we're able to build up the construction subtotal, or the base costs for construction. And then the final stage are the additions for project delivery, so contingencies and professional services. So at this stage, again, we're an early stage, we're at concept stage, and we recommend a 35% contingency on top of the construction base estimate. And this really is an allowance for funding risk. It's an allowance for all the unknowns in the project. And at this stage, we have a lot of unknowns. And that could include typical things that can contribute to significant increase in costs as a project proceeds. Our ground conditions, so if we get to a site and the ground's very poor, then all the excavation costs increase, the foundations get more complex, the costs go up. Material cost fluctuations, particularly in today's economy, we see huge variations in relatively short amount of time. Could be material costs, also things like diesel costs to run the plant on the site. Month to month, year on year, that can fluctuate considerably. And then contractor availability. The amount of people available to do the work versus the amount of work they already have. That can lead to projects being charged at a premium. And then next we have the allowances for professional services, so legal and engineering costs. So that's to take the job from this stage, which is concept, through the detailed design development, through the bidding and proposal stage, so going to market, through the construction stage, through commissioning and handover. And again, from comparable projects and large capital projects like these, we typically find that comes out as about 20% of the overall project costs. And then finally, we have administration costs. And this is an allowance for the BPW to administer and to oversee the project delivery. Again, from concept stage all the way through design, construction, and then to handover. So we can go to the next slide, please.
Can I ask a question about the construction survey or for suppliers? How wide an area are you using for soliciting that information?
For the equipment suppliers?
Yes, and contractors in this area.
Yeah, so for the equipment suppliers, we speak to the local reps that supply the equipment in the Delaware area. So we typically in this region, different types of equipment. There are the actual manufacturers, but most of them are supplied by reps, and we have contacts with them, and they work directly in this area and specifically in the Delaware area.
And what about the general construction contractors?
Yeah,
Tom, maybe I can take that. Is for the
yeah,
general
absolutely.
for the general contractors, we have an average that we use across the industry, but really that's based from North Carolina up through New York. So that 35% is really what we see in the industry.
All right, thank you.
And when we get our standard rates that we use for each of the individual activities and line items, we try to look at comparable projects, and we try to look as close to the region that we'll be working in. So we do a lot of work. We see a lot of contracts come through in Delaware, Maryland, Mid-Atlantic region, as Jeff was saying. And we look for the most recent market rates that would be applicable here.
Any questions on this portion right now? Barbara?
Barbara Curtis, Ship Carpenter Square. I didn't have a problem with the cost estimates. I think that it's quite apparent that, you know how to do a cost estimate, engineering costs, big project costs, that sort of thing. My concern with the cost estimates was the design upon which they were based. And if you go with different technologies, or if you go further down the road on design issues, the impact on the cost estimate and the actual costs will be significant. And so I think that maybe if some of this response is because I was uncomfortable with the cost estimates or questioned them, it was because of that. I think, if we do hardening to 2040 or 2035, it would be a different thing. We wouldn't have to, if we expanded the plant by 25% capacity, do we really need 600% expansion in the equalization tank? Those kinds of issues that I'm just having a hard time getting my head around. And also the issue of, when we get to option 3, the technology that might be used there.
And I did not mean to, there were actually other people who made comments on that, so that was in.
Tom, you had to say something about that.
Sure, Hans.
And, in certain one of the different options, the treatment technology plays an important cost factor. In others, and I think slide number 13 speaks to that, when you come to large land cost factors, and their treatment option becomes pretty much not irrelevant, but much less relevant. So that's why I think at the one option, the treatment is tied in. Remember, we have no choice in one, because the treatment as it exists today will be expanded in its form. Now, you could say, why does one not look at alternative? And yeah, but I have a sort of response for that, because it is difficult enough to expand an existing treatment plant. It gets much more difficult to change the technology and expand on a traditional treatment plant.
Yeah, and I think the other thing I would just add on to that is it's difficult expanding a facility in general, but the tight space that we're in would make the risks associated with it very large of keeping the existing plant operational while you're either changing or expanding. So, if it was a 200-acre site, we had lots of land, you could build a new plant, but that's not where we have. All right, Tom, back to you. for the eye test.
Yeah, so just and this has already been touched on. If people are interested, the itemized cost estimates are provided. They're in Appendix D of the report, and you can see the breakdown line by line to see how the costs are made up and to see what the major components are. But if you can go to the next slide, I just wanted to touch on a few specific examples. So that's the cost estimating process. That's how we get to the bottom line numbers. And then this is the summary table that we've provided in the report. And there are a few key cost differentiators between the different options. And I think we've received some questions around some of these as well. So I just wanted to touch on a couple of specific examples relating to land purchases and network upgrades. So again, if we can go to the next slide, please. So starting with land purchase. So the costs in this category vary considerably from $0. And again, the costs that we present in the report and that are shown in the tables here are the costs that would be incurred by the BPW specifically. So the cost for land purchase would vary from $0 up to 12.5. And I'll go through each option and talk about the assumptions that were made. Now for option one, and it sounds like from the discussion earlier, we may need to include a clarification on this, but option one does require an increase in the existing wastewater treatment facility site area of approximately 0.3 acres. That is to accommodate new aeration basins and the MBR building expansion. Now, as we understand it, the BPW already owns the land around the facility, and therefore the assumption is that no additional land purchase is required for option one, hence the $0. But Austin, from the discussion that we had earlier, is that correct, or is it more nuanced than that?
No, you would have to do an adjustment, and I hope the city wouldn't charge anything more than.
So there would be an adjustment required.
Yeah, so what happened was that one parcel was originally deeded to the commissioners of Lewes. It has since been subdivided to the existing site of the wastewater treatment plant, and so we would have to adjust that line, and it would kind of follow the same process that we're doing now. So,
okay, thank you for that clarification. So moving on to the option two sites, starting with option 2A, and as a reminder, option 2A is to construct a new wastewater treatment facility at a high elevation site and then discharge the treated effluent via spray irrigation at an application rate in line with the local regulations. Now, in order to do this, we require a 250-acre site, 230 of which would be for the land application of treated effluent. So it's a large land area. By far the largest land area that would be required, hence the high cost of $12.5 million. And that would represent land purchase for option 2A as a significant proportion of the overall cost. It's about 13.5% of the total construction cost estimate for option 2A.
So Hans, when you look at those numbers of 2 inches per acre on a 7-day period, is that realistic? Set of numbers? Because you guys do this.
It's somewhat on the high side. We discussed that back and forth, but it's we didn't want to drive the cost artificially through the roof. Only the soil investigative report can really tell you. But for example, the highest number we have it in the base, each field gets rated, by the way, individually. The highest one we have it in the base is 1.9. But soils
and that's over a 7-day period.
1.9 inches per 7 days. But
And is that seasonally adjusted, I assume, or?
There are max flow rates and seasonally adjusted. But the Wolf Neck has a slightly higher rate, but we found out that the 2 inches, even at Wolf Neck, which is more granular, is the 2 inches per week is sort of the go-to number.
Thank you.
But it will be refined once we have a site evaluation report, and then
I know all these options are subject to inflation, and probably this is probably impacted more. Because I think land values in this area particularly have gone up quicker, I mean, and higher than other products such as equipment. So this could be a little bit low in today's market, I think, for land.
And we tried to establish kind of a benchmark of east of Route 1 and west of Route 1. The issue you run into is that when you try and look east of Route 1, the feasibility of trying to find a parcel that not only it could accommodate the plant, but could accommodate the plant with a proper buffer creates complexity.
They're not in my backyard, principal.
Are you offering?
No. My backyard's not that big. I wish it was.
Barbara?
Barbara Curtis, Ship Carpenter Square. One thing that impressed me at the tour of the South Coast facility was how close it was to residences, and there was no odor. And so that gave me a whole different outlook on siting issues. Another issue that may be unpopular, but I'm going to raise it just in case. You know, the county is leasing land from the state. Why could we not lease land from the state? Say in parts of Cape Henlopen Park that are higher elevation. If you have a plant that doesn't smell, why not? Why not look into that as a huge cost saving kind of thing?
And it's something that I think we did consider. One of the issues is it doesn't get you far from the ocean. So while even the land, when you go in the park, is higher, you still have the wind loading, hurricane loading, storm surge issues, even more amplified because you're closer. So that's another one of the trade-offs, let alone you'd be going and asking for a permit in the state park. We could put a restaurant in with it. Okay, Tom, you want to go on?
Sure, thank you. Okay, so now moving on to option 2B and 2C. So again, that would be a new wastewater treatment facility at a high elevation site, but this time the site would be much smaller. So without needing the additional area for the spray irrigation for the land application, it's a smaller site area, therefore a smaller cost. Now for these sites, the land purchase, I mean, it's still we still have it at $1 million. It's not an insignificant amount of money, but in terms relative to the overall construction cost estimate, it actually only comes in at about 1.5% of the total estimate. So it's not one of the major contributors to project cost. And under option 3A and option 3B, the new county facility will be constructed on land already owned by the county. It would not require a capital cost contribution from the BPW. And again, these cost estimates are all the costs that would be incurred by the BPW, and therefore no additional land purchase, no additional cost component under option 3A or under option 3B. Any further questions on?
Just one, this is all, so obviously you've been through these numbers before with us. Is there, and there's the 35%, variance, I get that. How confident are you of these numbers versus where you were when you first put them out? Are you more confident, less confident? I mean, are we continuing to educate ourselves and adapting, or is this is the line in the sand?
I have the same confidence in the estimates as when we put them out. The only slight caveat I would say on that is that we did the report in 2022, so these are all in 2022 dollars. Other than that, I have the same level of confidence in the values now as when we first published the report.
And it's the same thing with the land. When we were looking at land, we looked at land that recently was closed in a relatively close area within the last 2 years. And we just did it on Sussex County's deed search. So
Yeah, and they're, you know, the thing is that these costs are all consistent with each one of the alternatives. If the BPW selected an alternative as we went into schematic design, which would be 30%, you know, we would update the cost and let the BPW and the county know what those costs are. And they do fluctuate, or also, you know, we are in a tough economy, still impacted by COVID.
Okay, thank you.
Okay. Any other
Okay.
questions, or move on to the next slide, Tom?
Yep, next slide, please. So the next sort of category of costs from the summary table, which is a major differentiator, are network upgrades. So network upgrades are all the costs that are required to transfer raw wastewater to a treatment plant site and to transfer treated effluent away from a treatment plant site to the discharge location. And these vary considerably, again, from $0 all the way up to 49 million. And I'll just talk through each of the options one by one, so you can hopefully get a better idea of where those differentiators come in. So starting with the existing option one. So it's the existing site, it's already plugged into the collection network, the lift stations are already in place and they already discharge directly into the treatment plants. Therefore, no additional network upgrades are required. There's already an existing outfall to the canal. And so the network upgrade costs are zero. Moving to option 2A. So the network upgrades would include a new raw wastewater pump station, which is outlined in the report. That's to consolidate flows on the network and pump them up to the new high elevation site. As well as the pump station, we also have the transfer pipelines. And pipelines in public roads are expensive. It's a considerable cost component for any project like this. As well as the material costs themselves for the pipes, you also have to do the excavation in the roads, the reinstatement, temporary traffic management. And once it all comes together, it's a significant component. And as outlined on the previous slide, for option 2A, we need a large land area. And whilst we haven't identified specific plots of land in any of these cases, we have been working on an assumption that in order to get a large enough area of land, so the full 250 acres, the treatment facility would have to be moved further out of the existing downtown area, therefore further away from the raw wastewater pump station, so there'll be longer pipelines. So that does increase the cost for the raw wastewater component. Now, also under option 2A, the treated effluent is discharged via the spray irrigation, as we've discussed, and this will be close to the treatment facility site. So what does help keep the costs in for this option is that we don't need the additional network upgrades to transfer treated effluent all the way back to an outfall. And the outturn of this is that we have a network upgrades cost estimate for option 2A of 9.5 million, or about 10% of the total construction estimate. So it's still a considerable component of the overall estimate. Moving on to option 2B, again, we have the raw wastewater transfer pump station, but now because we are only looking at a 20-acre site, we've made the assumption that that could be closer to the existing treatment facility, therefore shorter lengths of pipeline, therefore lower cost. However, under this scenario, we also need to pump the treated effluent back to the existing canal outfall. So as well as the pipeline out, we have to have a pipeline coming back. And that results in an overall network upgrades cost estimate of 13.5 million, or 20% of the overall project cost estimate. Now, under option 2C, which is similar to option 2B, but rather than going back to the existing canal outfall, we go beyond that along, and you can see the graphic here on the slide, through Cape Henlopen Drive, and then out to a new ocean outfall, 6,000 linear feet off the existing beach. As you can imagine, if constructing pipelines and public roads is expensive, doing anything out offshore is an order of magnitude higher. So in order to get that outfall in place, we need to do horizontal drilling and sections of marine open cut trenching, which are very expensive construction techniques. And I've included an extract here from the itemized cost estimate for option 2C, specifically for the ocean outfall. So you can see all the components that go into here. As you'd expect, the big ticket items are the offshore sections, so the drilling and the marine open cut trenching, There's also everything else that goes along with that. There's the staging areas, there's the drill pits, there's concrete ballast for the pipe so it doesn't float away, there's a diffuser arrangement, and everything all the way down to silt fences and temporary fencing on the beach. And the outcome of that is that we have a network upgrades cost of $49 million. And the majority of that comes from the requirement to go out offshore for the new ocean outfall. Now under option 3A and option 3B, and again, these are the costs for the BPW. Sorry, is there a question?
Look at those numbers, do they, because I know you involved with your home with and other things, do those numbers make sense to you?
For the size of pipe they do.
Would you recommend this, was it 16? Would you recommend a larger or smaller pipe? Just curious.
No, that's the right size.
Okay.
I mean, you could go 14 if you had equalization.
Thanks.
Okay, so for option 3A and 3B, so the BPW, as discussed before, would only be responsible under the existing BPW county agreement. BPW will be responsible for a new raw wastewater pump station and also the length of raw wastewater pipeline from that pump station up to the existing agreed scope boundary, which is close to the location of the existing outfall of the canal. And the remainder of the pipelines would fall within the responsibility of the county. So under these options, we have network upgrade cost estimates of $4 million. Still significant quantities, and in terms of the overall cost that the BPW will be responsible for, they make up 35%, close to the construction estimates. So that's all the content that we wanted to cover for cost estimates. Hopefully that provides a bit more of an insight into how the costs are developed and also where some of the major cost differentials come from and are generated when we compare the options. But if there are any further questions,
Different options, certain things obviously would take longer, an outfall pipe would take longer than, making sure the wastewater treatment plant had a barrier around it. Is that taken into consideration on your math on how much these things will cost as well? In other words, when you're looking at something that's going to take longer, are you increasing the cost of that because of inflation and other things?
No, these capital cost estimates are all in 2022 US dollars. So this assumes that these would be the rates that would be supplied at bid stage.
So, and I'm not a bidding person per se. So if we look at bids, I'm looking at you here. How would someone calculate what the costs are, right? When they're doing something that's really going to take place over a period of several years.
So Tom, maybe I can take this. Earl, it would depend upon the options, but, starting with option 2C, that could take 5 to 10 years to permit. So
that's not taken into consideration. It sounds like what we're doing is we're saying we are shovel ready. Here's how much it's going to cost.
Correct. So there's more risk with the cost of option 2C versus the option 1 or option 3A and 3B because they own the land now. Option 2A and 2B and 2C all rely on us purchasing new land, getting the permits, constructing everything, which provides more risk. But if in my 30 years career, I would say that the biggest risk for the options would be the land application and the ocean outfall.
So should we have a model that actually gives our customers an idea on what this is going to cost? If something's going to take 5 years to do, should we put the uplift factor over those 5 years for the cost of that particular solution?
We could do that, and we would have to, of course, use some judgment there. So it's not going to be perfect, but it's based on experience, what we would have experienced before.
Well, this is perfect easy either, right? If something's going to take us 5 years to do, it's going to have a lot higher cost than what this said.
But and correct me if I'm wrong, Tom and Jeff, but any one of the options is going to take us 4 or 5 years at a base.
Yeah.
the ocean outfall is potentially 5 to 10. So, for a apples to apples comparison, maybe you're right, we need an uplift for the ocean outfall. But the other ones, and Hans, correct me, are all in the same time frame.
Yeah, they're all in the same time frame. I mean, I'm familiar with present worth analysis. But it really comes down to your world of expertise, what you plug in for inflation and what you plug in for return of money. If your return investment, if we're using USD advisor, hey, we're golden, the longer we push it out. I mean, these are the two big, when you look at the present worth analysis, these are the two big drivers.
Well, option one, as an example, we could do that rather quickly, right?
Not the wetland permitting for a large marsh, no,
How long would that take?
at least a year.
Okay, a year versus 5 years.
No, hang on.
That's a year for permit.
That's for the.
That's for the permit.
No,
I get it.
the treatment plant expansion will have to work its way through the permitting process, the public hearing process, the commenting process. Remember, we are in year 5 at any bit. If you'd get it done in anything less than 2, I would be totally shocked.
So if we look at all these different options here, are they all within 5 years? Do you think all at 5 years, or some sooner or some longer?
The option 1 is definitely shorter, but keep in mind, design, let's say design takes a year. Permitted takes you 2 years, 3 years, you're putting a shovel in the ground versus 10 years on the ocean outfall. That's the span.
But 3 years for shovel in the ground and then a year of construction.
Yeah, but I mean, like, just
Yeah.
when we're talking about,
2 years.
I was thinking pricing. So for option 1, you would have a price in hand, a bid in hand at the end of year 3. For the ocean outfall, you'd have a bid in hand at the end of year 10. That's where the present worth analysis would have the biggest impact.
I would think that we should have that built into this model, so we actually know what we're paying for when.
No, everything, the present worth brings everything to today.
Understand.
It's just a little bit more complex than just using 2022 numbers.
You're talking for all the options.
Well, we
You'd like to see
can
that.
select certain options, certainly, but it would seem to me that we need to have a really firm understanding of how long it's gonna take and what the cost will be at that particular time.
Because ocean outfall option is so much larger than the others. Even if it would just get worse if anything.
Yeah.
So I think it's pulling away already, and we could do that. I'm not sure it'd be very
But
productive.
at some point, we need to be able to tell our customers what their bill is gonna be.
Right. And
And then if you're gonna do that, you've gotta have math that projects it out over a period of time, and you can back it in. I get that math as well. But we need to be able to tell our customers, here's the solution, here's the cost of that solution, and here's why it's the right solution. And I think until you do some of that math, you're not apples and oranges.
But we're in the conceptual stage at this point. These things are so fluid. I mean, you could try to work it down, but I think they've done a pretty good job of that already at conceptual stage of what the costs are and so forth. And Hans has come up with some ideas about costs from the treatment plant. I think we're trying to make something tighter today than we really have the information to tighten up. I think we could work that out. Spend a lot of time trying to do it, but I'm not sure how valuable it would be at the conceptual stage.
right, because if all of them are in the 4 to 5 year range, then for narrowing down the choices, we're looking at apples to apples. And I agree with you, if, eventually, we're gonna have to get hard numbers so we can show what the effect on the bill is. But if they're similar in timeframes, you have to get to a lot of more detailed engineering to get to that point. And we're trying to narrow it down, so we're not going after 6, 7 options.
Look, I'm okay with narrowing it down.
And let me chime in one more time. I'm changing hats.
Mine or his.
Mine,
I like your head.
Vice Chairman of the Water Infrastructure Council of the State of Delaware. So we look at subsidizing projects above and beyond the 1.5% of median household income of the service area. So if you, and that is of the latest available census, but Delaware consortium numbers. So you're probably running in the 70,000 in your service area, give or take. So if that project were to materialize today, you would, the average customer would have to expect the $1,500 per year rate. Nothing less, absolutely. And by the way, these numbers don't include wage rates. So if you take the state's money, that number goes up. But the good news is you're still locked at 1.5%. So it's sort of a, once you're over that, it really doesn't matter anymore. So if your customer, if you want to tell your customers, if we funded the project today, expect to pay $1,500 a year.
But the timing is helpful to know, when does that, whatever the number is, when does that start to affect customers?
The day you close the loan. So let's say in order to award a project, you have to have the money. You go through the application process, the money's made available, you close the loan, that day repayment starts.
And from today, where we are, and not gonna make a decision until maybe June or July. From that point on, what is the time frame for closing a loan on any one of these options?
Are the,
So that the customer, you know, the ratepayers know, okay, it's gonna take a year anyway before you start getting a bill anticipating a loan closing and spreading out the pain of what this is going to cost for as long as possible.
it would be a minimum of 24 months because you would go through the notice of intent process, state priority ranking. You have to be on the project priority list for a year before you can even receive an application invitation. So when you stack all these up, let's say if you took these numbers today and get yourself on the 2024 project priority list, by the time you then file the application, because you need the engineering report and the environmental assessment to back up your application, by that point, you're looking at the end of 24.
And then you're paying interest only payment, even though you close, you pay it. Go ahead.
As soon as you close, you have to pay the minimum interest on the loan.
Until the project's.
You
closed
can
down.
choose not
Yes.
to repay capital. However, it shortens your term.
Yes,
So we have to ask
Yeah.
our finance expert whether that's a good choice or not. So some people choose to start the payments, principal and interest. Other people choose to just pay the interest.
so like if you have a 3-year project, you can choose to pay interest only over the 3 years, draw down on the loan amount, and then when you're done, then you would start taking on principal and interest payments.
Well, what I learned today is that these numbers are 2022 numbers, with no projection out, excuse me, over time. And I don't think that's a good model to have. I think at some point, I'm not saying we do it today, but at some point we need to have, you know, a select number of options and actually do the long-term math. Because we've got to end up showing our customers at some point, what you're saying, here is the cost of this process. And here's how much it's gonna cost you over some period of time. I get there's nuances.
No, there's really no nuances because the only nuance is Rehoboth choose to pay out of pocket versus go for a referendum and issue a bond. So if you choose to pay your project out of pocket, there is no limit on the top. If you choose to get the author, and I don't even know what the requirements are for the Lewes Board of Public Works to incur debt. And Mike can chime in on that, but, so that's the fork in the road. How do I finance my project?
But even with that fork in the road, your customers eventually need to pay that debt down. And so, there could be other nuances that can help you subsidize it. But at the end of the day, there's a cost that has to be carried per option.
And in Rehoboth's case, I was part of the rate study. Once the decision was made and Jeff was part of it and the estimates were in hand, the city went through a considerable rate study effort to establish under which scenario, what would be the rate. So that's another component
That's basically what I'm asking for.
which goes beyond, what we're talking about today.
Did Rehoboth do that through a consultant?
Yes.
Yeah. So they basically they narrowed it down to a certain option, call it 1, 2, 3, A, B, C, whatever you want to do.
Mhm.
They went to a consultant and said, this is what we got. Tell us what it would cost. Estimate.
We need to get there. We need to narrow it down and we need to get there.
Yeah, absolutely. And right now we have too many options and we need to start winnowing them down. So, Summer, sorry, you've been very patient.
That's okay, because most of the question may have been answered by the discussion here. I really, really appreciate the complexity here. I guess what I was 10 minutes ago, trying to look at the eye test that's on all these screens. And I now will go back and look at the details, although I don't have, for example, Mr. Webb's background, and it all starts to make my eyes glaze over.
Is that me personally or my back?
I don't know, maybe. When I look at these different options, and I have to say, the more I hear you ask me the first time I stood up here last time, did I have something I thought could be knocked out? I do. I don't know that I need to share it right now, but it's pretty clear to me, at least one of these things we can knock out.
No,
but
just go ahead. I mean,
I think this is crazy right here,
which
option 2. The
The
whole thing.
outfall.
Yeah, but if I'm understanding the numbers right now, we're looking at capital expenses. And to Earl's line of questioning, we're trying to figure out how we're going to manage that cost burden from the capital expenditures. What about operations and maintenance? They're in there? Okay.
they're in the report also.
All right, so I'm sorry. I
No,
couldn't
no.
figure it out, but I just want to second what Earl is saying, because I think ultimately for us all, however many options you need to knock out before you can actually start to address what it's going to cost us on a monthly basis and for how many months, years, whatever it's going to take. I think that's the thing that's going to help us all.
And if I may, I would just add to that, when we did the operation and maintenance customers, we did do a net present value analysis, which included allowances for inflation, because it's an ongoing cost over 20 to 30 years. So that is included in the operation and maintenance cost estimates.
And just, briefly, and you can correct me or fill in, the operation and maintenance, we know that the current plant, being an MBR, has higher energy costs considerably. We know that with the county, the agreement that we're trying to work up is pro rata flow split for operation of the plant. So it's not something that is, at risk or that they will change on a yearly basis. It's pro rata, if we're 50-50 flow, we get 50% of the cost of that plant. And, they have union contract or union labor, those rates are more well-known. So if you look in the maintenance, the O&M portion, you'll see those line items in there. Tom, Jeff, you want to chime in a little?
No, I think that's a good summary.
Okay.
Yeah, I think the only one that I would also state is that there's risk with each one of the alternatives. risk if we selected option 2C tonight, that doesn't mean we're going to get a permit. We could go through the permitting process and be told no, and have to go back to part 1 again.
That goes the same with 3B with an artificial wetland. Man-made wetland.
Mhm.
It could be, and so, there is risk in 2C. So we can develop costs that go to 10 years, but the MCA is where we talk about risk and the ability to get the permits. But, understand that there's risk. So I think if we're going to knock some alternatives out, we should definitely be bringing in the risk component of ever being able to build it.
Yeah, and as was pointed out, the MCA table has all the specific criteria and the relative weightings for them. Permitting, siting, cost, impact on the public, all those things, so. And then we went and divided the total cost by the rankings to get a cost to try to, normalize and be able to compare them to each other.
Yeah, that's a really important point, actually. Probably should have prefaced it before getting into the cost estimates, but we have a section 4 of the report is evaluating the options. And one component of the evaluation is cost and the other is non-cost. And that's where the MCA comes in. And that's why we factored in things like permitting complexity, expected implementation duration, short-term, long-term impacts to the community. It's to try and capture those nuances that are not necessarily dollars and cents, although a lot of them do directly translate into cost as well. But really, the evaluation should be viewed as a whole.
Yeah, and for those that aren't familiar with the acronyms that are kind of being thrown around there, MCA stands for multi-criteria analysis, where we look at all non-cost items.
Okay. I guess at this point, Tom, we'll go back to the water quality criteria.
Absolutely.
Slide
If
16.
I can get the slides up. Okay, thank you. And yeah, so the third topic that I wanted to touch on today is water quality criteria. And this, understandably, there have been a lot of comments received about this. Now, you may recognize this diagram. This is not new material, but we have tried to develop some additional material, which is on the next slide, which I'll come to in a moment, just to really clarify some of the key points we're trying to make here. So apologies for those that have tuned in the past. Some of this will be a repeat, but I just want to go through and talk through the discussion step by step. So the graphics that we're showing here are their ways of representing the waste load allocation in terms of total nitrogen and total phosphorus for treated effluent coming from a wastewater treatment facility under different scenarios. So what we're showing here are the permit limits. We're showing the existing plant, both as it operates now and at capacity. And then we're showing, we have representations for the options outlined in the long range planning study. So 1 and 2, and then 3AB. And I'll just, and again, some of this is repeat content, but it's obviously a key point for the whole study. So if I'm going to work through the chart from left to right. So on the left-hand side, in the dark blue bar, and I'm going to focus on total nitrogen, but it's the same principle for the phosphorus. The bar in blue represents the total waste load allocation for total nitrogen noted in the existing permit, which is 100 pounds per day. Now the permit limit represents the expected performance of the existing wastewater treatment facility at the rated treatment capacity, which is for 1.5 million gallons per day, 1.5 MGD. It also corresponds directly to the design criteria for the wastewater treatment facility. So in the green graphics, these represent the existing plant. Now at the moment, the plant operates at a lower flow rate, a lower average flow rate than the rated capacity. So for the data range that we reviewed as part of this work, the average daily flow is about 60% of the rated capacity. Now this is and again, we presented this before, but this is a long range planning study. So when we project out to 2050, we fully anticipate that those flow rates coming into the treatment facility will increase. And as the flows increase towards the rated capacity, the monthly average concentrations and the total loads will trend towards the permit limits. That's to do with the loading coming into the treatment facility, but it's also to do with the flow rates. So with a higher flow rate, there will be a reduced retention time in the aeration basins, and so the extent of nutrient removal will be reduced. It'll still be in line with the requirements of the permit, but the performance will differ from what is observed currently, with the plant running at approximately 60% capacity. And moving on to the future options that are outlined in the long-range planning study, which are the yellow bars. A key principle that we've outlined that underpins the whole study is that any future wastewater treatment facility will meet all of the conditions of the existing discharge permit. That means that the total waste load allocation, the total pounds per day of total nitrogen or total phosphorus, will still meet the requirements of the permit, which is 100 pounds per day in the case of total nitrogen. Now, for the future options, we're also looking at increased flow rates. So in order to maintain the total waste load allocation of 100 pounds per day, with an additional volume going through and being treated, the new wastewater treatment facilities will need to maintain concentrations below the stated permit limits. And the concentration values are in light blue. They're the ordinates that are called out on the trend line. And that's something we've received a lot of questions on. So I just wanted to go through in an extra level of detail how we come up with these figures. So if you can go to the next slide, please. Thank you. So just to emphasize the point of how these numbers are generated and how the different options relate to one another, we've got some example calculations, 3 example calculations. The first one relates to the existing plant at design capacity. So we're looking at the treated effluent total nitrogen concentrations. So the existing plant at capacity, the waste load we anticipate will trend towards the permit limit, which is 100 pounds per day total nitrogen in the treated effluent. The rated capacity of the plant is 1.5 million gallons per day treated flow. So in order to get a concentration of total nitrogen going out into the canal, we divide the waste load by the volume. So we get 100 divided by 1.5, 66.7 pounds of total nitrogen per million gallons treated per day. Now, to bring that in line with the units used on the discharge permit, we convert the pounds per megagallons to milligrams per litre, which is an established unit conversion. We divide by 8.34. That's where we get the value of 8 milligrams per litre total nitrogen concentration, which is present on the existing permit limit, and is what we anticipate that the existing plant, as it reaches capacity, would trend towards in terms of total nitrogen concentration. Now, the next 2 example calculations relate to the future scenarios, and they're different due to the flow rates that are involved. So for option 1 and for option 2A, B, and C, the new wastewater treatment facility would treat up to 1.75 mgd. And under the option 3 scenario, partnership with the county, it would be 3.5 mgd. So again, the underlying principle for all of this is that we meet all of the requirements of the existing permit. So that means the waste load has to remain the same. The total pounds of nitrogen being discharged, irrespective of the outfall location, would not increase beyond 100 pounds per day. So we still have the value of 100 pounds per day. We have a consistent waste load allocation, but now we have increasing flow rates, so increasing volumes, which means we decrease the nutrient concentrations. So in terms of total nitrogen, the treated effluent will be more dilute. And so we get concentrations of 6.8 milligrams per litre, and the lowest of all would be under the option 3 scenario of 3.4 milligrams per litre. That's what the new treatment facility will be designed to do. And these concentrations and providing treated effluent at these concentrations is within the functional limit of the treatment technologies that we've assumed for concept development purposes. So now's probably a good time for me to pause for questions. Hopefully this does answer some of the questions that have been raised around this. If not, I'd be happy to take some more now.
Mark Prouty. I have a question regarding the total nitrogen for the option that takes one of the options, number 2, where the effluent goes to spray irrigation. There would be 0 nitrogen, if I'm not mistaken.
No.
All effluent would be irrigated, is that correct?
The effluent would still contain.
It would still contain nitrogen.
Yeah, but there would be no discharge, so your effluent quality criteria is 0.
Wouldn't. Sorry, Hans, please go ahead.
You have to have a detailed knowledge of the state regulations with regards to spray irrigation and how that's permitted. So it assumes that on the annual average, your crop yield takes up the nitrogen provided in the wastewater. So that means on an annual basis, that is correct. But during the summertime, you actually have to use startup fertilizer to even get the yield in order to do the uptake. And in the wintertime, you have either dormant growth or no growth. And so in the wintertime, whatever is in the wastewater goes in the groundwater. But the theory behind the state regulations is that on the annual average, that averages out. But I'm saying theory.
Yeah, I understand. So what you're saying is that the effluent nitrogen from the spray irrigation system is measured at the input to the groundwater, not on a discharge to a stream or canal. Is that correct?
It's measured in the percolate.
In the percolate. Okay, I just think that everybody understand that it's not, when you use the terminology discharge,
No, it's
leads
absolutely.
people to think that it's going to be going to
No.
the stream at that level.
Well,
Go ahead.
I would just make the point. So the terminology treated effluent, irrespective of the discharge methodology or the discharge location, a wastewater treatment facility has treated effluent. So even under option 2A, where the discharge methodology is spray application, at the point that it leaves the wastewater treatment facility before it's spray to land application, that is treated effluent, and that would still be subject to these permit limits. And that flow leaving the facility would be bound by these restrictions and these total nitrogen concentrations.
Well, we made an assumption for all of our alternatives, Mark, to stay within the existing waste load allocation. That decision was made by the BPW and the county for all options, because we needed some target to assume what level of treatment to provide for each one of the alternatives. So with regards to 2A spray irrigation, yes, it could be a different number, but for the purposes of the report, we kept the waste load allocation the same for all alternatives.
I understand.
And
Thank
there's-
you. I just want to make sure that everybody understands that not all of those numbers are being discharged into the canal, that some of them are being irrigated with some crop up there.
Yeah, that's the beauty of it, is that it doesn't get to the surface water for the most part.
Precisely. I just think that everybody ought to understand that
Good point.
that are being talked about are appropriate to a system that in spray irrigation that decreases the ultimate nitrogen into the canal.
Because with spray, you're required to monitor groundwater levels of nitrogen, so you can't exceed the 10, I guess it's still the 10 limit.
There is a mandatory note in the state regulations which says the operation of the facility cannot degrade the groundwater supply. So, and that has been interpreted differently over the years, and I'm not gonna put that third hat on. I'm not the regulator. But the county has been subject to the regulation interpretation. We're abandoning the Piney Neck site because the interpretation has been made. If you're neighboring groundwater supply wells do not meet drinking water standards, you are the contributor and hence have to cease and desist. So it is depending on where you site your facility, if there's legacy groundwater nitrogen contamination, it can be an extremely high hurdle to cross. Because you are essentially made responsible for meeting that criteria.
Just one second, just with the lay public, what I think I'm hearing everyone say though is that the calculations here on loadings, it's the permit loading at the discharge of the plant, not to the environment or, way downstream. So all the permit limits are, if you cut the pipe right there.
But you can get higher permit limits with an irrigation system because it's not going into a surface water.
But
If you can show that the vegetation is applied to is taking up the best portion of that. And so that you design the spray irrigation system to meet the criteria of the needs of the vegetation. So we could spray a lot more nitrogen on a field of grass or any type of grain than you can on, say, I don't know, beans or trees or other things. So the best thing to use with irrigation is some type of grass material.
Right, but I was pointing out that the reason why the limit, these are all limits assuming, it's at.
But they have
discharge of
different,
the
they have
plant.
different impacts is the
Yeah.
point that I'm making.
Sumner?
So, Sumner Crosby, Hans and I had a discussion, a really wonderful conversation after the last meeting that I attended about this issue that he just raised. And the very real challenge of nitrogen charged groundwater getting into all the waters that matter to us. I'm just going to ask him, I have other things I wanted to ask. In your experience, how much of the groundwater underneath this part of Sussex County isn't going to be bound by that very situation you just described? I get the impression a lot of the water is pretty charged already.
Very much so, and pretty much all of it, yes. I mean, you can look at the various drinking water supplies and you see what the average nitrogen number is. It's definitely not pre-Columbian, I'll tell you that much.
Right.
That's because most of it's been in ag operations.
Right.
Where they're have historically over fertilized.
Right, that's what I'm getting to,
Yeah.
is when I was at EPA looking at groundwater, everywhere we looked, we found pretty high concentrations of nitrogen. So I didn't know what Hans said a few minutes ago, but it makes perfect sense that you would have to reevaluate facilities. First of all, just want to applaud the new revised graphics here. I, for one, have been somebody asking for clarification, and I really like what this is. But this actually helps me present the question, the basic question that I have. I have two things. Hopefully I'll remember the second one. My basic question that I've struggled with here is, if I read this graph that's on the screen right now, looking at the existing plant data and the height of the bar, the green bar, the second from the left, we're discharging 40 pounds per day of nitrogen. Under any of the other options, we will be discharging 100 pounds of nitrogen. And yes, in order to not go beyond that 100 pounds, you have to squeeze more out of the system. However you do that to get the concentrations down so that you don't exceed the 100 pounds. So the basic question I have, and obviously it's a little too early to tell, is does that make a difference? I think I may have said something like 2.5 or 3x. Maybe I even said 6x because I wasn't doing my math right. My worry was pounds of nitrogen that ultimately are in the receiving water rather than the concentration at the discharge point. So I'm curious how that works. And I guess one of the things that I didn't realize is that in the screen right before this one, I think, there was a point that Tom made. It's at the bottom green item here in the comments below, as flow increases toward the rated capacity. It begs the question, if we wanted to reduce the loadings, what does it cost to add more retention? Is it prohibitively expensive? Am I reading that right?
Yes, in theory, yes, you would need more facilities. Couldn't tell it would be prohibitively expensive, but it would certainly increase all of the costs.
I mean,
Yeah, I mean, we could go to reverse osmosis and pretty much remove everything, Sumner, but the electrical cost to do that would be immense. And at the same time, when we did this study, we talked to the BPW, and what they didn't want to do is get into another very complex system, because there were issues with getting qualified personnel to Delaware to be able to operate that in this area.
And I appreciate that.
but there's one other thing to be said. This is to squeeze another 10 pounds or 20 pounds of nitrogen out of any of the three 2050 scenarios. The energy cost is much higher, and we know where that goes, all right in CO2. But you also have to look, if we do another remediation project like the county does routinely, the Herring Creek project alone, removing 900 septic systems out of the Rehoboth Bay, is equivalent to the full allocated permitted Rehoboth Beach discharge. This one here takes about 500 systems. If we take 500 systems out of the Rehoboth Bay, it would be equivalent to 100 pounds.
Right.
So-
I appreciate that calculus, but that's over a big area. The receiving water, based on calculations that have already been made, is more headed toward the Delaware Bay rather than.
Exactly,
Rehoboth Bay.
but I'm saying at the worst case scenario, if all the water stemming from the Lewes BPW discharge ended up in the Rehoboth Bay, that 100 pounds, if we take 500 systems out, would be more than compensated, would be reduced to zero.
Okay, and I appreciate that. So the question is, how can we do that here? I mean, I realize we're shifting. If we go this way, well, we're not. It's all coming back here. My greatest worry has always been the impact to the water quality of the canal. The concentrations look wonderful. To me, it's all, and maybe I just can't get this through my thick head.
Well,
To me, it just comes down to what impact ultimately to the receiving water. 2.5 times increase in the pounds loading.
But
will
what
do.
we haven't accounted for, I mean, we've talked about it, but we haven't accounted for is in the option 3, they're only going to discharge on the outgoing tide. So it's going to flush the canal, as opposed to all these other ones, it's a constant. Because we don't have the ability to put in the retention lagoons at the site to be able to do that. So,
So if half the time you're discharging water and you're averaging it out on a daily basis, that means the concentration when on an outgoing tide is what?
Still the same concentration, just double the flow.
Okay, double the flow. All right, fine. All right.
But if I may, just one other thoughts on that is the fact that when you look at all the scenarios here, you remember these are all 2050 scenarios, and we're comparing them to 2023. I have
Fair enough.
a difficult time with that. And the other one is the canal study with the full base symmetry, the full nutrient analysis, all that in the model will tell you, what is the incremental impact of that?
Right.
And at that point, I either say, you're 100% right with your concern, or you will say, I was totally off the chart.
I hope that's the case.
So,
Absolutely.
but
Yeah.
neither one of us will know the real answer unless we go through that. And I think the county is fully committed to the canal study.
Right. And so I'm here to say, it's a clear enough option that we need to explore that and as soon as possible, figure out how to get that ball rolling.
I mean, that
Thank
would
you.
Start write the contract for GHD to start the canal study.
Before we go on, Barbara.
That was very helpful. Thank you. I appreciate it. But a question I have is, we're looking at nitrogen and phosphorus. What about other pollutants in the wastewater? And how will that change if we're combining with Sussex County? And how do we see it changing with regulations coming down the pipeline? And has that been part of the analysis, or is that something that when we get to the part of negotiating a new NPDES permit, we'll deal with it then? But certainly we need to have an idea for design of a new plant. What?
I'm gonna let someone smarter than me answer that one.
The
I'm not necessarily smarter, but I have some experience in wastewater treatment. So what the other constituents that the NPDES has is waste load allocations for TSS and BOD. And each one of these treatment alternatives will be able to stay within the original waste load allocation or be less than what we had for the current NPDES. So the similar approach we would take with those versus as we are with nitrogen and phosphorus. But really, we get BOD and TSS reduction by doing the additional nitrogen and phosphorus reduction anyways. So we get it as we go.
So just for everyone, TSS is total suspended solid.
Sorry.
BOD is biological oxygen, biochemical.
Biochemical oxygen demand.
So let me chime this one in here, Jeff. I think I know Barbara a little bit better than you, just by the sheer pleasure to have talked to her a few times. I don't think she was referring to BOD or suspended solid. So if I may guess, you're talking about forever chemicals, PFAS, pharmaceuticals, you name it, right? So will you want to try the answer again, Jeff?
Well, yeah, and I can, and thanks, Hans. Yeah, I kind of go right to what is the regulated constituents at this time. I guess, right now, PFAS and PFOA, we really don't know what those limits are going to be for a treatment facility. And, it may be that these systems don't have a lot of that in them anyways. I will tell you that with respect to having a centralized facility versus multiple facilities is that as regulations change, if per se in 15 years, the state comes and says, we really have to do better water quality, we need to do additional treatment for these constituents, having it in one location is easier to do than having it in 3 or 4 different locations. So if there comes a time when we decide we really need to just treat this water to drinking water, being in one location, we can do it easier and more cost effectively. So the same thing goes for PFAS treatment and PFOA, is if we really need to add activated carbon or granular activated carbon on the back of this facility, it's more cost effective to do it in one location than 3 different locations.
And Jeff,
just one thing on more.
Yeah.
And footprint wise, once again, option one, we've got a limited footprint. The other ones would be either procuring land or the county has quite a bit of land, so.
And Jeff touched on this, and I think, Barbara, you can probably appreciate that. Being the former public works director of Kent County, I am painfully aware of industrial discharges. Kent has a large industrial user base, and you can see wide swings in, and Ray knows about that too. Kent County's facility would see wide swings in water quality in really, let's call it, non-traditional parameters. So we have the luxury of having a very stable discharge base, like what you see in the unincorporated area versus the Board of Public Works Service territory, that water quality coming in, the incoming, is very similar. I've looked at their numbers, they looked at our numbers. I'm sure Charlie looked at both of them before. They're not these tremendous swings you can see like in King County.
Charlie?
Just a couple things, Charlie O'Donnell, GMB. I just have a couple things rolling around my head with the third bar chart item about the existing plant at capacity. I know that it appears that the plant's getting additional retention, 0.48 million gallons. Was that factored into that BO or the nitrogen loading trending towards 8 parts per million?
Would be for Tom.
Yeah, for Tom.
Tom, Jeff?
Yeah, what we did there, Charlie, is with our experience with membrane treatment, we looked at, expanding the flow to 1.75. We looked at the influent BOD, total nitrogen levels, and then made recommendations or design criteria for what the retention in the aeration basins must be to kind of maintain a maximum mixed liquor in those tanks. So yes.
Okay. And then just the last thing I'll say is anybody who's been to any board meeting over the last 15 years knows that the TSS and BOD concentrations leaving our facility now are negligible. So, I mean, it's one thing to compare it against the permit limit, but it's another thing to compare it against what actually happens from our plant.
Sumner?
So I actually had the same industrial fluctuation thing in the back of my mind, and I'm really glad that you addressed that, Hans. And again, I'm not a civil engineer. Maybe this is all crazy, but the one thing I haven't really heard much about is bacteria. It sounds like this plant, just as Charlie just said, this plant does a stellar job of removing bacteria. How will the technologies under 3A3B work in that? Because that's not really in the permit, is it?
It is.
It is.
It is.
Okay, so is it virtually going to remove it the same way, or will we have to accommodate, will we see more bacteria in the discharge? We haven't seen any graphics. Describe that.
The disinfection technology, whether, regardless of which technology you choose, is definitely capable of reducing the bacteria to the required levels. Now, in my opinion, having run fairly large UV systems, having designed UV systems, it carries the greatest risk of bypass failure. I mean, chlorine, chloramine, bromamine, these are just like guaranteed killers. So.
But just to clarify, if we were to use a chemical treatment, it has to be, you have to deplete the chlorine or bromine before it goes to the environment.
In the spray irrigation, you have to maintain a residual at the spray head.
Well, true for spray.
So, right, so that would be my only concern if we're discharging some level of all those things you just said into the canal. Does it change the environment? Does it change the impact to the biota? Are we going to smell chlorine as it's coming downstream on an outgoing tide, et cetera, et cetera?
If you point discharge, you have to fully dechlorinate.
All right, cool. Thank you.
On the spray, it's just the opposite.
Okay, is there any questions online? No?
Just one comment. Have anybody ever heard of MBWA? Anybody familiar with that concept? Hewlett Packard started in the 40s. It got popularized in a book in 81, I think it was. Management by Walking Around. You've heard. I walk 2 dogs around this town every day, twice a day. And when I first started that process, call it 3 months ago or 2 months ago, everybody was talking about how the plant needed to be the best plant that it could possibly be. Everybody was leaning in very hard on the environmental side, as I do myself, by the way. What I'm starting to hear now, I'm starting to hear a change. And the change isn't necessarily technology based at all. That's not what's changing. What's changing is how much is this going to cost? That's what our customers are starting to lean into now. And I think that's positive because I think people see consolidation in certain areas that some like. I think we need to have a chart, and we can't vote on this because it's in a workshop. I believe we need a chart from 1 to 2 to 2B to C to 3A to 3B. It looks at what are the probabilities, what are the hurdles, and what are the probabilities of success? What's the cost of those? Again, time, present value of money based on the timing that we've got. But if something's going to take 5 years to get even possibly done, we now have a wastewater treatment plant that's leaving the water for 5 years. So I think we need to have a very holistic, and it's easy. It's just this simple chart. It's cost to customers, it's water quality, and it's the probabilities, et cetera. I think we need that for at least the top 3 things that we're looking at. That's how we're going to make the best decision. And again, that's not a votable thing. That's my perspective.
Any other comments from the board?
Another good meeting.
There's another, one more slide.
Anything from GHT?
There's one more slide.
I know, I was gonna get to that. I'm just doing a poll right now before. So,
Good.
Barbara,
Barbara Curtis, Ship Carpenter Square. The people I've spoken to about this whole issue, it's still the concern about control. And I don't know how flexible Sussex County can be with the agreement that would get negotiated if we get into option 3, and that appears to be the best. But if we could negotiate some level of participation by Lewes BPW, going not just, well, in the design and going forward in decisions, I think that the people in the city would be a lot more comfortable with that option. Just a comment.
and that's exactly where we're at right now, is because if we can't come to, as I said in the front, a financial, environmental control, long-term aspect agreement with the county, then option 3 falls by the wayside and we need to look elsewhere. But that's what we're putting the flesh on the bone right now. And, hopefully by the May meeting, we'll be able to flesh that out.
I hope so. I hope so. And then, of course, we have to wait to see what the modeling comes back for the increased volume to the canal.
Well, that's a 1-year process. 2-year. Yeah. That's what, none of these,
Yeah.
everything is in the 4 to 5 or the 10-year with an outfall. I mean,
And that's a $500,000 project.
Wow.
Yes. That's not top back of the envelope.
But correct me if I'm wrong, county council would have to vote on that, and my guess is county council would want some sort of direction from the BPW in a 3A or 3B manner before they allocate any sort of funds for that study. You can't speak for them, but I'm
Yes,
just
I mean,
saying.
like the question begs to be asked, why would the council consider to do a study of the canal where we have no discharge in the canal?
Yes.
Robin, Austin? Oh.
I'm Jerry Burton. I just have a thing with the county. We already know there's two counties. There's the Western County and then the shore. And we kind of get outvoted unless we have somebody from BPW or something higher representing us than the one councilman, county councilman. So I'm very leery of being thrown in with the county. Because again, they can outvote and raise us. Possibly, there's all kinds of factors. So I'd rather stay something within our area. That's just me. And again, we already know there's two counties. And, every time for years, we've always got to vote it down on the beach areas as far as development. No, that's just highlighting that. That's just something I'm just throwing there. Okay.
Thank you.
Thank you. Thanks, Jim.
All right, so as I mentioned earlier, the county has agreed to host a tour of the Wolf Creek facility. It will be on April 28th at 3:30. What did we say, 10 people?
No, what I would say is we'll take RSVPs and kind of gauge the interest.
So we have to keep it to a manageable size, but
Sorry, Thomas. The inside facility holds about 10, 12 people max. Before we spill into the hallway, it has a fairly small conference room, even, the size of South Coastal. So, if we had 20 people and it's a rainy day, it's sort of limited. We have no problem on the outside. We can host any size just on the inside.
okay. Charlie, did you have something? No. Oh,
And if anybody wants to attend, please RSVP with us, either through Sharon, the office, or me, just so we can keep a track.
as I said before, we'll have 2 more workshops in May and June. They are up on the website. We will take the feedback from here and, as I said, kind of fine tune some of the details and present back in May. And as I said, we'll continue the discussions on the agreement with the county. And we're aiming to narrow the options down so we can do a deeper dive. But doing a deeper dive into all the options, as I've said, would just be, cost prohibitive and not a good use of funding. So with that, anything else for the cause? Anything online?
How many people are online, by the way? Good.
All right, then we have a motion to adjourn.
So moved.
Second.
All those in favor? Aye. Thank you all. We'll see you in May. Enjoy summer.